Hello, everyone. This is the t-test on SPSS using SPSS. This is for the independent t-test, right? This is where you are comparing the means of two groups that have no relation. There's no relationship between the groups. So there's just two groups. There could be your control and your experimental, or the men versus the women, or Ohio versus Michigan, whatever the groupings are. Those are the two groups. And so you would have your data set would look something like this. So you have here your variables, and you see the variables are toxin and yield, right? This is the data set that we had looked at previously. So here we have a measure of how much toxin was found in each of the corn yield. And then here is the measure of, or the recording of, what type of or what category this, you know, particular yield fell into. And so there were only two categories. One was labeled 4, the other was labeled 8. So when you want to um, conduct run a t-test, right? So always, you have to go to analyze, and then you will check comparison of means, because that's what we're doing. That's what a t-test is. A t-test is always the comparison of two means. And we're doing an independent sample t-test. So here we have our values that we're going to be finding the mean of and comparing. And then here is where you would define your groupings, right? So we have to let SPSS know that one is called 4 and one is called 8. And once you have done that, then you can go ahead and generate your t-test. And so this is what it would look like. You would have these three um, table outputs. And the first one is the descriptive statistics for your data set. So you see the 4 grouping and the 8 grouping, they showing you how many members, subjects, participants, or in this case, yields are in this group. So there were 16 eights and 16 fours. And so the average toxin level for the fours was 14.68, and then the average for the eights was 8.42. So there's a definite difference in the average for the two groups. But what we want to determine using the t-test is whether or not these two the difference is statistically significant. Here the difference is really large, so it's kind of easy to tell, but sometimes you will have means that are really close together, and you won't be able to tell whether the difference is statistically significant or not. And so this is what this table tells you here. And so the first thing you want to pay attention to, it's this middle table, the significance, or the two-tailed test, right? So the two-tailed meaning we're looking for whether they're larger or smaller. We're not, we haven't chosen a direction. We're just comparing. And so here we see this significance value, or a p-value, is showing that it is less than 0.05. And so we can then say that indeed this is a statistically significant result. And as such, we have to neglect our null hypothesis. The null hypothesis will state that there is no difference. So we will reject our null hypothesis in favor of the alternative that there is a statistically significant difference, right? And this is the difference between the two means. 14.6 minus 8.43 that's what gives you the 6.25. So it's already been calculated for you. These other measures, the F statistics is telling you whether there is equal variation or variance within each of the group, so in terms of the standard deviations, are they the same? So that's what these measures tell you here. But in our case, both of them, whether we assume that there is a difference or not, the